This video, we're going to talk about 10.2 Objective 3, where we test for independence using a two-way table. I've written a couple formulas up here at the top for us that we're not going to do things a whole lot this way by hand, but if you were to do these calculations by hand, the formula to find the expected value would be to take the sum of the row times the sum of the column over the grand total for the entire table. And then once you had all of those expected values in a table, then you would take the difference between the table entries for O and E. You would square them. You would divide by the table entry for E. Once you got that value for each of the entries in your table, you would take the sum of all of those to get your chi-squared test statistic. I'm going to let my calculator do all of this for me today when we need to make the calculations. That's why I have the calculator open over there. So when we are doing this chi-squared test, we're testing for independence. So our null hypothesis is always going to be that there's no relationship between the variables, and that the alternate is going to be that there is a relationship between the rows and columns. When we have a two-way table like this, remember that we're just splitting things up into two things that are a variable that is represented in rows and a variable that's represented in columns. So they've already done the work for us to give us the test statistic here, and they've given us a significance level, and they want us to look up a critical value from the table. So we have a 2x2 table. It really doesn't matter what it is, but we have a 2x2 table with an alpha of 0.01. It's 2x2 alpha of 0.01 is 6.635 for our critical value. Then we compare our test statistic, which was 5.955, and that's less than our critical value. So we do not reject our null hypothesis, and we say that they don't appear to be related. We'd only say that they appear to be related if the test statistic was in our rejection region. And so we're over here with our critical value of 6.635. And there's a tail that's over here. And we're over here at 5.955. We're not in that rejection region. Let's go ahead and try this one now. It's also a 2x2. It has a alpha of 0.05 this time, giving us a critical value of 3.841. Still have the same type of H naught HA, where there's no relationship between the rows and columns in H naught, and there is a relationship between rows and columns in HA. Let's see. And we have a chi-squared test statistic now that is greater than our critical value. So we do reject the null hypothesis, and the responses seem to be related to the sex in this case. Sex and response do appear to be related. Right, let's go ahead and state our null and alternative hypothesis here. Row and column variables are independent. Alternative is row and column variables are dependent. Alpha is 0.05. And we have a 2x2 table. So let's go ahead and let's look up our critical value. 3.841. And I'm going to go ahead and enter this into the calculator. This is just the easiest way, in my opinion, to do this. Go into your matrix menu, make a 2 by 2 matrix to represent this table, and enter this table of values: 16, 44, 32, and 8. And then we're going to go into stat tests. We're going to look for our chi-squared test, which is right there. It's letter C for me. We've just put our observed in matrix A. It's going to write the expected into matrix B. We'll do that towards the end here, since we want to see everything else on our screen first. We're going to calculate here. I'm going to come back up here, and I'm going to say that my chi-squared test statistic to 2 decimal places is 27.35, and my p-value, which is how I would make my decision here, is 1.697269312 times 10 to the negative 7th. That is definitely less than my alpha, so I would reject H naught. They're going to make the decision because the test statistic is greater than or equal to the critical value, that this 27.35 is greater than or equal to that 3.841. So they know they're in their rejection region. They reject H naught. The variables appear to be dependent. There does appear to be a relationship between whether the subject lies and the polygraph test indicates lie or truth. Let's go ahead and let's look at those results from matrix B here. And we get 28.8, 31.2, 19.2, and 20.8. And again, we rejected H naught because we were greater than or equal to the test statistic. They're dependent, and there does appear to be a relationship. Right, let's go back into our matrix menu, and we're going to edit, and we're going to put this data in now. 193, 247, 41, 85. And then we're going to stat tests. We'll run a chi-squared test again, calculate, and we get that chi-squared is right here, rounded to the nearest hundredth, is 5.18. Null hypothesis is that they are independent. Alternative is that there is a relationship. Alpha is 0.05. And critical value 3.841, or bigger than that. So we're going to reject H naught. There does appear to be a relationship. We can also see that with the p-value of 0.02, 28558325, which is less than alpha. So we're not in our rejection region. We can make the decision either way here. Let's look at matrix B now and see what our expected values are that go in our table to the nearest 10th. 181.9 to 58.1, 52.1, and 73.9. All right. Now we're going to have to construct the table for the observed values ourselves, given what they tell us here. So they tell us that there's a total in this row of 96, and there's a total in this row of 92. And they told us that of these 96 here, 59 showed improvement, and of these 92, 47 showed improvement. So we need to figure out the no improvement here. 96 minus 59 is going to give us 37, and 92 minus 47 is going to give us 45. Our null hypothesis is going to be that the rows and columns are independent, and our alternative is that rows and columns are somehow related. Let's go ahead and run our hypothesis test on this. Make sure that I've entered the data. Yeah, I didn't, so need to run that first. 59, 37, 47, and 45. Now we're ready to run that hypothesis test. There we go. We get a chi-squared value of 2.055. And our critical value for a 2x2 table for alpha is 0.05, is 3.841. Chi-squared is less than alpha, so there does not appear to be a relationship between improvement and treatment. Let's go ahead and look at matrix B here and round these to the nearest hundredth. 54.13, 41.87, 51.87, and 40.13. Okay. Number 6, null hypothesis is testing for independence. Alternative is that there's some relation here. And we now have 2 rows by 3 columns. So I'm going to go into my matrices here, and I'm just going to delete. It's the easiest way to get rid of them. And I want 2 rows by 3 columns this time. My data is down here. 14, 378, 727, 37, 103, and 640. 0.01 level of significance for 2x2 or 3x2. So we have 9.210 for the critical value. And let's run our test. We get a chi-squared value of 116.324, which is definitely bigger than our critical value. So we are going to reject H naught, and there appears to be a relationship. Let's go ahead and let's look at matrix B now. And we're going to round these to the nearest tenth. So 30.1. Let me just do this. There we go. 283.4, 805.5, 20.9, 197.6, 561.5. And there we go. That's it. And this was our last video for Math 155 topics. So thank you for watching, and good luck with whatever comes after this.